Good afternoon, this is Schweitzer and welcome to our little introduction to significant digits. So our first question here is, what does it mean for a particular substance to, or a number to be significant? Well, in this case, it might seem a little bit obvious, but for a number to be significant, it needs to have two different things. One, a number has to have a value. And two, the value must be known. That may seem kind of strange because most numbers that we deal with, 1, 2, 3, 4, up through 9, every number for that matter, except for one of them, which would be 0, always kind of fill this role. A 1 is 1, and a 2 is 2, and 3 means 3 things. So whenever we're using a number like 1 through 9, they generally are significant, meaning that they have a value and their value is known. So 0 is something that is playing multi-roles, and really a 0 is something that's going to be the main focus of our particular discussion here today. Okay. So how can a number not have a value? Like I said, 1 through 9, they're out. They have a value. And they would be read off of some sort of tool, like a tape measure. And you just look at it, you come to a 9, and there you go. But how would a number not have a value? And that only way that could, well, the only way that can really happen would be if it's a placeholder. And we'll see this happen in a little more in the future here as we start looking closer at this. But if I look at the number 0.00020, let's say 24, okay, and really these numbers here, they don't have a value, okay, nor does that number right there. Or this 0 is here, so the number hasn't even started yet. My accuracy cuts off right here. The number isn't started yet. It's just very small. I sometimes call this my rounding line. By the way, it's the point where the tool has lost accuracy. So you might think everything before it is good to go as far as being significant. Everything after it, it's like looking through a telescope. Your telescope can only see so far, and eventually it's no good. But these numbers aren't even numbers. In fact, I could just do this. We could have done something like this: x, 2, 4. They could have done that. It's kind of telling us where this little decimal point is as a reference point. So these numbers are, not that they're even 0, they're more along the lines of null value, meaning they don't even have a value. Computers-wise, computers definitely know the difference between a 0 and a null. Null means nothing. It's not even a number. Alright, so how can the value of a number not be known? Well, I've kind of hinted this already. Sort of mentioned or sort of gotten to this point a little bit in the past here. A tool can only see so far. And doesn't mean the numbers aren't there anymore. It's just kind of cut off by its limitations of the tool. So I don't know what these question marks are, and there's some more afterwards, but I can't see them. Until we get down really to the atomic level, the numbers keep going. And even then, some might say that they continue. But at this point, tool B seems to be more accurate because it can see farther. Accurate. Okay? Is it possible for a non-zero number to ever lose accuracy? Well, the answer is yes. To never lose accuracy. Alright, so, for example, if I have, let's see, I got myself, my cat. Alright? My cat here, I only have one cat. His name happens to be Fatty. And that means I have one cat. Or I have 1.000 cats. Yes, that's exact. I still have that cats. This number, 1.0000000, is can go on forever and ever and ever and ever. And we call that infinite number of figs. We'll talk more about that as we kind of move along here. Okay? Can't have half a cat. So it's a whole number, item here. What does it mean to be an exact value? Do we have a tool measuring our value? So this kind of the key thing here is that an exact value has no tool. Okay? So I say I have 1 cat. And I mentioned that eventually, most numbers, the tool runs out and you got this little rounding line. But since there's no tool, there's no rounding line. That number just keeps going on and on and on and on. So I might say if I got 5 meter sticks, in that case, I have an infinite number of significant figures. I have 5.00000000, and all those numbers are just as good as the first ones. Accuracy goes on forever. But if I line all those 5 meter sticks up in a line, 3, 4, and 5, do I have exactly 5 meters? And the answer is no. Because these meter sticks have an accuracy, and that accuracy runs out. So this would be a measured value. Okay, and a measured value can never be exact. Can never be exact. Okay, so whereas an exact value is exact. Okay. How do you become exact? There's a little video on that you could look at, but essentially, it kind of has to be a whole number thing, right? And you can have no tool. So even a thing that's a whole number can sometimes get so big that we can't count them. Like, let's say bees, for example. All right, you got 10,000 bees, or really anything for that matter. Okay. When things start to get too big, we sometimes estimate them. You know, you could walk into a room and you could see in the room that there's, you know, look around, oh, it looks like there's 10 cats here. Well, is there 10 cats, or are you estimating? If you said there was 9 cats there, that'd be different. But that 0 sometimes can play a role of an estimate. So, you know, we tend to be a little more pessimistic about this. But, in some sense, I think we can move on here. Okay. So, what does it mean to be exact? Look at this again, this idea of exact versus estimate. Cats. So an exact value is going to play a little bit different role than an estimate. Okay. So when I say 200 cats, okay, I am going to say, okay, my accuracy cuts off right here, and I have 1 significant figure. Because I don't know, you know, is the person that wrote this out, are they talking exactly 200 cats, or are they saying estimate 200 cats? Now, if you said 201 cat, then I would think you'd have 201 cats exactly, and you have infinite number of sig figs. So we're going to put the burden of an exact number on the person who wrote it. If they say you have exactly 200 cats, then I'm going to go with that for infinite, but that's going to be pretty tough. Okay, we're going to be very, we call, pessimistic on this thing. That I need to know for sure they're not talking about an estimate. If I don't know, I don't know. I'm just going to go with my tool to be the weakest tool possible. 2 for 200, 1 sig fig versus infinite. Now, how could I get this to work? Well, I could have 215 cats. Okay, so it's got to be a whole item, and you got to see there's no zeros. I don't want any zeros on the end here. All right. I want to make sure it's a whole number there. That's a number I can count. I also got to make sure, for example, 212 gallons. Okay, I got to make sure this is not a measured value. If it's a measured value, gallons, then you know I can't have an exact gallon. Okay, just like the meter sticks, I got to make sure that this thing does not require a tool. No tool required. Now if it says 212 gallon jugs, well, then I know that this is an actual item, and I can have 212 of them. Okay, so make sure it's not an estimate, and that it's a whole number item, and that whole number can be actually counted individually up, and not using a tool. Alright, okay, so what do we need to actually consider to be exact? Which of these are exact? Go ahead, pause the video, give it a try. Alright, so now, again, I'm going to put this on here. 200 decimal. I don't know. I'm going to go right here. 1 sig fig. Right here. 1 sig fig. 200 cats. I still don't know. 1 sig fig. Alright, looks like we got some funny business here. 0.02 of a cat. All right, well, I don't know. I guess it looks like they're measuring something about the cats with a tool, and I'm going to go right here and say maybe we got 2 sig figs. Or I might say here, it looks like we got, I don't know, 200.0. This is a little bit of funny business going on here. I don't know what you mean by 0.0 of a cat. All right, but I'd probably follow my standard rules, which you'll see here in a little while, that my tool's measuring up to that point. All right, so I'd probably say I got 4, but this is something that would be unusual situation. Probably not something you're going to see. It could be cats per person or something like that, where you might get something like that. But you can't have a fraction of a cat. All right. I don't know if any of you guys are cat lovers out there, but it seems like people either love cats or they hate cats. All right. Now, 221 cats, exact. So, all right. All right. So, what about zeros? Zeros can actually mean a number that is nothing, or not even a number. Okay. So, 0 can actually mean a number that is nothing. Not even a number. So I mentioned this before here that 0 can actually mean a null value. Okay. Or a 0, so that'd be like 0.0005, grams. In this case, these zeros are not significant because they don't have value. And the only significant number I have here is this one, which is 1 sig fig. Fine. My tool runs out right here. Zeros can mean a number that have a value. We just don't know what it is. And this is the case of the estimate, which we've already talked about. So, 200 people. Probably sick of cats. Alright, so we estimate how many people show up for the wedding. There's about 200 people. Do we know there was exactly 200 people? No, we don't. We call this an estimate. And those zeros are not, right? My tool runs out right here, and I only have 1 sig fig. Okay. Alright, next one here. So, just kind of highlight some things here and categorize them in maybe a little different way. And you'll learn some stuff here too. So leading zeros. This is going to be the zeros that are in front of a number. That are in front of the tool, you might say, like this. Right, these guys here are not significant. Doesn't mean they're not important. They are important. They're shown with the decimal places. They're just not a value. A trapped 0, 505, let's say, for example, that guy there is just like just means a 0. Means the actual number 0. And yes, it is significant. Now let's look at trailing zeros. Of course, we got to be cautious of these things we call estimates. Estimate zeros are not significant because they don't have the value there. So let's look at what this might be. And is it a 0? Is it an estimate? 200, it's 200 meters from here to the office. How many? Where's my tool cut off? Right there. And I have 1 sig fig. If it's 200.0 meters from point A to point B, now you're revealing where, here was a little bit of a question mark. I don't know where it is, where the tool ends up, so I'm being extremely pessimistic. But in this case, I'm revealing that my tool measured all the way down here, and therefore I have 4 sig figs. This can sometimes be an issue for people, so put a little example on your note card. If you go past the decimal point, we can show exactly where our accuracy runs out. It reveals it really cleanly that my tool ended right here. If I do 200 like this top one here, I don't know, because I got to show where the decimal point is. So that estimate is not using the zeros as necessary as zeros. Alright, so that was the tough one there. So how do we deal with scientific notation? There's a common radio station my daughter really likes, which is 101.1. This thing's been around forever. Megahertz. And in this case, this means 101.1 e to the 6th hertz. That's the frequency of it. So that's a scientific notation, meaning 101, 1, and then 2, okay, then like this, hertz. So it looks like that. 101 million hertz. Where's my tool run out? Well, it runs out right here. And that right here. So all the numbers that are listed here are significant. Okay? And that's what we use scientific notation. A couple of practice questions. Pause this out, try it out on your own, then rerun the video here. Alright, 12 dogs. That's infinite. 1.25, that's 3 sig figs. Alright, my tool runs out here. There's no tool to run out here. So no line means it's infinite. Okay? If you can't put a line there, it's infinite. This runs out right here. I got 2 sig figs. This runs out right here. I got 3 sig figs. This runs out right here. I got 3 sig figs. Right here. And these guys don't count. 1, 2, 3, 4. Runs out right here. That pound is not, it's a measured value, so that cannot be infinite. So it's 2 sig figs. 21 people. That would be more like an infinite. This guy here, okay. My tool runs out right here. So 1, 2, 3, 4, 5, 6, 7, 7 sig pigs. Exactly 20 pigs. And they're telling you it's exactly 20 pigs. So that's infinite. We'll try one more. 2,000.0 pounds. And that guy would run up here, and that would be 4 sig figs. Okay. I believe that takes us to our end of our little sig fig journey as far as what numbers are significant. Thank you very much.